Welcome to Horario. My name is Soorya and today we are going to learn our class 10 second chapter, that is circles. Okay, so we may see many circular objects in our day-to-day life. So can you list a few circular objects that you see in our day-to-day life? Okay, so we may see pizzas, chapatis and driving steering. All those things are circular in shape. Okay, so when we say what is a circle, when we are asked what is a circle, how can we define a circle? We may say that a circle has a center, a circle has a radius, a circle has no edges. So we may say a lot of things like that. How can we define a circle? That is the next question. How can we define? So how can we define a circle? A circle can be defined as a collection of all points in a plane that are at a fixed distance from a given point. Let us define what is a circle. A circle can be defined as a collection of all points in a plane that are at a fixed distance from a given point. So this given point, it is called the center of a circle. That given point is called the center of a circle, and we are collecting all points from a plane that are at a fixed distance from this given point, and this fixed distance is called the radius of the circle. That fixed distance is called the radius of that circle. So the fixed point is called the center and the fixed distance is called the radius. Now let us see a few parts related to the circle that we have studied in our previous classes. Okay, now let us discuss a few parts that are related with the circles. How many points are there in a circle? We can see infinitely many points in a circle. Now if we take any 2 points, and join these 2 points by using a line segment, what does this mean? It is called a chord of a circle, that is a line segment joining any 2 points. Okay, we have infinitely many points in a circle. A line segment joining any 2 points on a circle is called a chord of a circle. Now if the same chord, if it is passing through the center of a circle, that chord is called the diameter. So what is diameter? Diameter is a chord that passes through the center of a circle. And we already know there is a close relation between diameter and radius of a circle. So what is that relation? Okay, the distance from center to any point on the circle, it is called the radius. It is denoted by r. So let me denote it as r. The distance from center to any point on the circle is denoted by radius and r. Okay, so this is one of the radius of circle and this is also another radius. So this diameter, so what can we say about the length of diameter? The length of diameter, it can be said as from here to here r plus r, that is equal to r plus r is equal to 2r. So the length of diameter is equal to 2 times the radius. Length of diameter is equal to d is equal to, so length of diameter, if I am denoting by d, then d is equal to 2 times radius. Okay, now what have we seen? We have seen a circle with a center and a radius, and the line joining any 2 points, it is called a chord, and the line which passes through the center joining any 2 points, it is called the diameter of a circle. Also we have seen the relation between diameter and radius of a circle. Now today let us learn a few more new things that are related with circles. Okay, so before that, all of you might have taken your notebook in front of you. So first itself, you draw a line segment AB. Okay, it can be of any length. Draw a line segment AB. Okay, I have drawn up one line segment. I'll name it as AB. Okay, now you have to draw a right triangle with AB as hypotenuse. Okay, with AB, this line segment AB as hypotenuse, try to draw a right triangle. You can use your set square for drawing that. So try to draw a right triangle with AB as hypotenuse. Just try. Okay, now let me draw. So you can use your set square for drawing that. Let me draw a right triangle. with this vertex as 90 degree. Okay, so we have drawn one right triangle with AB as hypotenuse. Is this the only triangle with AB as hypotenuse? Can we draw any other triangle? Just try, can you draw any other triangle with this AB as hypotenuse? Okay, let us draw one more. Okay, this is another triangle with AB as hypotenuse and this angle is 90 degree. So we got two right triangles with AB as hypotenuse. So let us try to draw more, but it is a bit difficult to draw all the right triangles on the board. So we will use Geogebra for drawing that. What have we done? We have drawn a line segment AB. Okay, and after that we are drawing right triangles with AB as hypotenuse. Okay, so let us draw two right triangles with AB as hypotenuse. Now let us see the same using Geogebra. Okay, so first what we have done, we have drawn a line segment AB. Okay, and after that with AB as a hypotenuse we are drawing a right triangle. That vertex is, and name that vertex as C. Okay, name that vertex as C. And what we have to do, we have to draw many more right triangles with the same hypotenuse. So how can we draw that? We will draw many more right triangles with AB as hypotenuse. So instead of drawing that, what we will do is just do animation on that point C. Okay, and what is the figure that we are getting? We are getting the figure as a circle. You can see the figure is a circle. Now we have seen there is a close relation between circles and right triangles. Now if we draw a diameter, okay, if we draw a diameter and if we join the endpoints of diameter to a point on the circle, okay, so last time we have seen this points, all the trace on was a circle, and now what we are looking is, if we join the endpoints of diameter to a point on the circle, what happens? What is the angle forming there? Okay, if we join the endpoints of diameter, so we name the diameter as AB. Okay, if we join the endpoints of diameter to a point on the circle, so let that point be named as C, and what is the angle formed there? Okay, we have to find the angle. So do one thing, you can draw a circle in your notebook and draw a diameter. So what is a diameter? A diameter is a line passing through the center. Don't forget, okay, a diameter is a line passing through the center. So you draw a circle and after that draw a diameter and put a point on the circle. Okay, just put a point on the circle and join the endpoints of diameter to that point. Okay, join the endpoints of diameter to that point on the circle. Okay, have you done? And with the help of a protractor, you just measure the angle. Okay, what is the angle formed there? What will be the angle formed there? And we can see the same using Geogebra. Okay, so a circle, we are drawing a diameter, okay, a point on the circle, and let us measure the angle. So we have seen the angle to be 90 degree. So now let us find out what is the angle formed at the point C. Okay, what is the C? We are joining the endpoints of diameter AB to the point C. Okay, you might have measured and you have got an angle there. Okay, don't tell me, okay. We can use algebra and find out the angle. So by using, to prove, let me join the C to O. Okay, we will join the C to O. We will get a line segment OC. And what is that line segment? With respect to circle, what is that line segment? It is radius. So OC, OA, OB, everything are radius. Now let us consider this triangle AOB. Okay, in triangle AOB. OA is radius as well as OC is radius. So what about triangle OAB? What about triangle OAB? It is an isosceles triangle. Triangle OAB is an isosceles triangle. So its base angles are same. So if this angle is x and this angle will also be x, which angle? Angle ACO will also be x. As triangle AOC, this triangle is an isosceles triangle. Ready? Similarly, we can say, so angle A is equal to angle OCA is equal to x degree. So what we got? Angle A is equal to OCA equal to x degree. Now similarly, if we consider triangle OBC. Okay, if we consider triangle OBC, what can we say about that triangle? OB as well as OC are radius to the circle and OB will be equal to OC. So same way, triangle OBC is also an isosceles triangle. So if this base angle, if we are naming it as y, so this angle will also be equal to y degree. Okay, that angle will also be equal to y degree. So in triangle OBC, angle B is same as angle BCO is same as y degree. Okay, why? Triangle AOB and triangle OBC are isosceles. Now you consider triangle ABC. Okay, now let us consider triangle ABC. So we have learned in our previous classes that sum of all angles in a triangle is equal to 180 degree. Sum of all angles in a triangle is equal to 180 degree. That is, angle A plus angle B plus angle C is equal to 180 degree. This we have already learned in our previous classes. Now what is the measure of angle A? Its measure is x degree. Okay, and what is the measure of angle B? Its measure is y degree. Y degree. What is the measure of angle C? Angle C no kya? This is angle C. So x, till here it is x and to here it is y. So what is the total measure? Its total measure is x plus y. Okay, so angle C is equal to x plus y is equal to 180 degree. Now try to prove x plus x. So what is the value? X plus x, it is equal to 2x plus y plus y. What is the value? 2y. Y plus y is equal to 2y is equal to 180 degree. So let me write here. So 2x plus 2y is equal to 180 degree. So 2 we can take common outside. So what remains? 2 into x plus y is equal to 180 degree, or x plus y is equal to this 2 taken to the side, 180 by 2, that is equal to x plus y is equal to 90 degree. Did you also get the same value 90 degree? Now we can see the same thing using the help of GeoGebra. Okay, so we have drawn a circle with center at O and let AB be the diameter and the point C. Now you just see the angle. If it moves, the C moves to anywhere, we can see the angle. It does not change. Its value is 90 degree. So what can we see? If we join, so from here we can conclude that if we join the end points of diameter, of a circle to a point on the circle, okay, if we join the end points of diameter, so here what is the diameter? AB is the diameter and the end points are A and B. If we join the end points to a point on the circle, the angle formed there is right. Okay, so in a simple way we can see angle in a semicircle is right. Okay, in a simple way we can say that angle in a semicircle is right. So once again, if we join the endpoints of diameter to a point on the circle, the angle is 90 degree, or angle in a semicircle is right. So if we draw a circle in a plane, the plane will divide into three portions. One is the region outside the circle, okay, the exterior of the circle, and one is the interior portion of a circle, and one is the point on the circle. Now we have already seen, if we join the endpoints of diameter, to a point on the circle, the angle formed is right. If we join the endpoints of diameter to a point on the circle, the angle is right. Now what happens if we join the endpoints of diameter to a point inside the circle? You put a point, you draw a circle, okay, with center O and radius, any radius of your wish, and draw a diameter to that circle and put a point inside the circle. Okay, put a point inside the circle. So let me join the endpoints of diameter to that point. Okay, so let me rub all those things. Ready? So, let this point be named as some Q. Okay. We are trying to see whether there is any specialty for this point Q. Okay. So, if we extend this Q to meet at the circle, let this point be named as P. Okay, meet at the circle, we know this angle is 90 degree. We know this angle is 90 degree. Now, we are seeing what is the specialty of this circle. So, we have already learnt in our previous classes for a triangle. So, for any triangle, the exterior angle at a point, any triangle, the exterior angle at a vertex is equal to sum of the interior angles at the other two vertex. Do you remember this result? The exterior angle at a vertex, okay, the exterior angle at this vertex is equal to sum of interior angles at these two vertices. So, here we can see this angle, okay, angle AQB, that is this angle, it is the exterior angle of the triangle PQB at the vertex Q. Okay, angle AQB is the exterior angle of the triangle PQB at the vertex Q. Okay, so angle AQB is equal to, the measure of angle AQB is equal to sum of the other two interior angles. The measure of angle AQB, by using this result, it is equal to the sum of angles at the other two interior angles. So, it is equal to angle P plus angle PBQ. Okay, that is equal to angle P, we already know it is 90 degree. 90 degree plus some value, we don't know what is that value, let it be X. So, anyway, what we are getting, this angle AQB will be more than 90 degree. Okay, that angle AQB will be more than 90 degree. So, what can we say? If we join, so you can measure, now you can measure your angle AQB. Okay, what you are getting, is it an angle more than 90 or less than 90? Okay, you can do by yourself. Now you measure angle AQB or put a point, another point C, and measure this angle. Just see what is the value. Okay, if it is more than 90, less than 90 or 90, what you are getting? It is more than 90. So, we can see what we have seen. If we join the end points of a diameter, if we join the end points of a diameter of a circle to a point inside the circle, if we join the end points of diameter of a circle to a point inside the circle, the angle is more than 90. So, what are the things that we have learned? If we join the end points of diameter to a point on the circle, the angle is 90. Inside the circle, the angle is more than 90. And now, one question rises, what happens if the point is outside the circle? Okay. Now, let us see what happens if we join the end points of vertices, the end points of diameter of a circle to a point outside the circle. So, draw a circle and draw a diameter AB to that circle, and now put a point outside the circle. Okay, a point, and name a point according to your wish. I am naming it as P. Okay. Now, what we have to do? We will join the end points to P. Okay. So, A to P and B to P. Okay. Now, we are focusing about the measure of angle APB. Okay. So, can you guess what will be the measure? Okay. So, here this point, we know its angle is 90 degree. Its angle is 90 degree. Now, what happens about this angle? It is also 90 degree. Can you guess why? It is linear pair angle. So, if I am naming this point as some Q, angle AQB and angle PQB are linear pair. Angle AQB and angle PQB are linear pair. So, what will be the measure of this angle? Its angle will be less than 90. Okay, we need not have mini proof and all. We can say from here itself, this triangle, this PQB, it is a right triangle. It is a right triangle. If this angle is 90, so it's these two angles measure, it should be less than 90. So, we can say this angle is less than 90. Now, if the point is here, what happens if the point is here? Name that point as M. What will be the measure? Actually, we cannot say the measure correctly, but we can say one thing, its measure will be less than 90. We can say its measure will be less than 90. Now, we can conclude. Now, let us conclude. Okay, what have we learned? If we join the endpoints of diameter of a circle to a point inside, to a point on the circle, the angle is 90 degree. So, angle in a semicircle is right. We have three regions. One is a point outside the circle, exterior, on the circle, interior. So, if we join the endpoints of diameter to a point on the circle, angle is 90 degree. If we join the endpoints to a point inside the circle, angle is greater than 90. And if we join the endpoints to a point outside the circle, angle is less than 90. Okay. Now, let us discuss a few problems that are related to this section. Now, let us do a few problems based on this concept. Okay, so first question. So, you have your textbook with you, page number 40, first question. Okay, so the question is, suppose we draw a circle with the bottom side of the triangle in the picture as diameter. Find out whether the top corner of each triangle is inside the circle, on the circle, or outside the circle. Okay. So, we have seen that angle in a semicircle is right. So, let us check if we draw a semicircle with AB as diameter. This angle is more than 90. So, let us recall our result. What we have learned, if we draw a circle, if we join the endpoints of diameter to a point inside the circle, the angle is greater than 90. So, let us recollect that. So, if I am drawing a circle with AB as diameter, so what happens? This angle is greater than 90. So, that C will be inside the circle. So, now can you say about the point D, where it will lie? It is 90 degree, so it will be on the circle. So, we can see the position of C is inside the circle. Why? C is inside the circle. Can you say me why? Because if we join the endpoints of diameter to a point inside the circle, it is more than 90 degree. It is 110 degree, which is more than 90 degree. So, C lies inside the circle. So, D, the angle D is equal to 90 degree. We have already learnt angle in a semicircle is right. AB is the diameter. So, AB is the diameter. So, if we join the endpoints of diameter to a point on the circle only, we will get 90 degrees. So, D is on the circle. D lies on the circle. Now, can you guess where E lies? E lies, obviously E will lie outside the circle because the angle measure is less than 90 degree. So, E will lie outside the circle. So, E lies outside the circle. So, this is a very important question. So, how to check whether the point lies inside, outside, or on the circle. Okay. Now, let us move on to our second question. Okay. I will read the question. For each diagonal of a quadrilateral shown, check whether the other two corners are inside, on, or outside the circle with that diagonal as diameter. For each of the diagonals of the quadrilateral, what do you mean by a diagonal of a quadrilateral? Okay. The line segment joining the non-adjacent vertices. So, we have one diagonal as BD. We will have one more diagonal, that is AC. Okay, we will have one more diagonal, that is AC. Now, tell me, if you join BD, okay, and if we draw a circle with BD as diameter, where will this A and C lie? That is the question. Okay, if we draw a circle with BD as diameter, what will be the position of A and C? Inside, outside, or on the circle? Okay, now you guess. Okay, you might have written your answer. So, where will be the point A? Its value, angle A is equal to 105 degree, greater than 90. So, what we will say? if we are drawing a circle with BD as diameter, the the vertex A will lie inside the circle. Why it will lie inside the circle? We have already learned angle in a semicircle is right. If A is lying on the circle, it will be 90 degree and it is greater than 90. So, it is lying inside the circle. Ready? Now, what about the point C? It is also lying inside the circle. Okay, since its measure is greater than 90. So, we can write the answer. If we draw a circle with BD as diameter, A and C will lie inside the circle. A and C will lie inside the circle. Okay. Now, we have one more question here. This is only one diagonal. We have one more diagonal. Which is the other diagonal? We can join AC. We can join AC, that is the other diagonal. So, join AC. Now, we have to find out whether this D and B are lying inside, outside or on the circle with this AC as diameter. Okay. But there is one problem. We do not know the value of D. How can we find out the value of D? Okay. So, we already know in a quadrilateral the sum of all angles is 360 degree. In a triangle the sum of all angles is 180 degree. In a quadrilateral the sum of all angles is 360 degree. So, we will find out the value of D. Okay. So, angle A plus, angle B plus, angle C plus, angle D is equal to 360 degree. What is the measure of angle A? 105 degree plus 110 degree plus 55 degree plus what we don't know, angle D is equal to 360 degree. Okay. So, what is the sum of all these values? So, 270 degree plus angle D is equal to 360 degree. So, what is the value of angle D? 360 plus 270, when it is taken to the other side, it is minus 270. 360 minus 270 is equal to 90. So, this angle is 90 degree. Now, our task is easy. Okay. If we draw a circle with AC as diameter, now can you find out where is D and where is B? Tell me. Yes, D will lie on the circle. D will lie on the circle. Why? Angle in a semicircle is right. And what is the position of B? It is lying outside the circle because its angle measure is less than 90. So, with AC as diameter, angle D is equal to 90, lies on the circle, and B lies outside the circle. So, what have we learned today? We have learned angle in a semicircle is right, and if we join the endpoints of diameter to a point inside the circle, it is greater than 90 degree. If we join the endpoints of diameter to a point outside, it is less than 90 degree, and we have done two problems on the basis of this concept. Okay. So, try to do the rest problems. If there is any doubt, just comment in the comment box. Okay. So, that's all for today. Thank you. Bye and see you in next class.